Imagine a world where you couldn't sense the touch of a loved one or the soothing evening breeze. Imagine a world where your body couldn't sense heat and you could be in severely hot or cold temperatures but not know until you have encountered physical harm just because you couldn't sense it. Well, I'm glad that's not the case and we don't have to imagine that. I'm definitely grateful for the work of the latest 2 Nobel laureates in physiology and medicine who have helped us understand more why we feel and how Hello guys, and welcome back to my channel. Thank you so much for clicking the link on the thumbnail that brought you here. My name is Evie and I make videos about science and my life as a graduate student. So I'm a third-year PhD candidate studying molecular biology, and today we are going to be talking about something I'm so interested and excited about. Every year since I started grad school, I get very excited when it's Nobel Prize season, and that's because I get to read the works of different scientists and actually really get inspired. You know, all those days of suffering in the lab, it's like, okay, maybe perhaps there is a prize, there's something you can actually discover, something that will be of immense I don't know, an immense contribution to the scientific world, maybe, who knows, and stuff like that. So it just helps me put my work into perspective, at least for the time being. So I'm very grateful that the Nobel Prize season is upon us again, and we have 2 Nobel Prize awardees for in physiology and medicine. 2 men, David Julius and Ardem Patapoutian. I do appreciate and honor, and I'm just in awe of their work, actually, both of them, because they've done so much in helping us see how we feel, why we feel some of the things, some of the sensations that we feel, and why we are able to sense touch. That's why the intro said, imagine a world where you couldn't feel your loved one's touch. That would be crazy. So yeah, we're going to start with David Julius. I did a little bit of research, and he's currently the professor and chair of the Department of Physiology at University of California, San Francisco. And he has a background that actually, he has a lot of associations with, MIT, also has associations with UC Berkeley, and, you know, very interestingly top schools. And I remember reading this to myself and I'm like, that explains it. Not to say people from other smaller universities haven't gotten Nobel Prizes, they definitely have, but I feel like the exposure that you have as a growing scientist definitely shapes the way you do science. And yeah, I felt like I could see that in his work. So basically, he helped us understand why we are able to taste pepper and also menthol. Of course, it wasn't that simple. It was a long research career to bring him here, I'm sure, him and his team. But he and his team actually were able to find out or discover the receptors that are involved with tasting pepper and menthol, and also what those receptors do apart from helping us taste pepper and menthol. So in chili pepper, and I mean chili pepper, not just any other pepper. So in chili pepper, there's a particular compound that is called capsaicin. This particular compound is what causes that pungent chili flavor that we get to experience. And what David Julius and his team did was that, of course, using a lot of molecular biology approaches, they were able to discover the name of this receptor and what it does. So this receptor is called TRPV1. TRPV1, that's the name of the receptor. And they also discovered that for menthol, which is called TRPM8, these 2 receptors are actually neighbors. They are family members, they are cousins, if you may. And very interestingly in his research was that he actually carried out more experiments. I don't mean just him, I mean he and his team majorly his team, I'm sure, carried out more research, and they were able to find that these receptors do not only help us sense or taste menthol or taste pepper, like my pepper soup, they help us also sense temperatures. So basically, the receptor that is that is responsible for tasting the peppery capsaicin, that receptor actually helps is activated in higher temperatures of over 45 degrees Celsius. And then the one that helps us taste and appreciate menthol, it is activated in lower temperatures of below 16 degrees Celsius, which makes sense because when you have menthol, you know there's that cooling sensation in your mouth. And so that's the reason, or that's at least one of the reasons we're able to know, oh yeah, this place is cold. And they actually confirmed this using mouse. So they knocked down the receptor, the gene for the receptor that helps us taste menthol from mice. And what they found was that the mice was not able to distinguish between a normal temperature and a cooler temperature of about 10 degrees Celsius. The mice basically was just comfortable, in quotes, in both of them. And I'm like, imagine if we didn't have that receptor. That would be wild. And I'm very grateful that these scientists were able to help us find out what that does and a little bit of how it works. Of course, there's still a lot of research that will have to be done for us to fully understand and appreciate even more what these particular receptors do. So that's David Julius and his group at University of California, San Francisco. I really love that during his Nobel Prize lecture, he had like a very elaborate list of all the people that were involved in this research, because we as grad students know that the research is done by grad students, research technicians, and maybe the postdocs, actually also the postdocs. So yeah, very grateful that he was able to acknowledge all of them, and very interesting to see basic research being appreciated for what it is. Now let's move on to Ardem P. Now his background was a little bit more interesting, at least to me, because he comes from Armenia. He has an association with University of California, Los Angeles, and also California Institute of Technology, but currently works with Scripps Research Institute. And what was very interesting to me was how that in his pinned tweet on Twitter, he actually said he's grateful for this country, which is America, for giving him the opportunity and access to this education, and also the opportunity to do basic research. And I could relate deeply to that because it's an opportunity to do science, and I'm glad that he actually acknowledged that. So to his work, he and his team actually developed and discovered, discovered the channels that help us be able to feel touch. So you see, all of these things are normal things that we do every day. We get to taste pepper, we get to taste menthol, feel cold, feel hot, feel someone's touch, yet we don't really think about how we are able to do all of these things that we do. But this particular researcher helped us see and understand what happens really when someone touches us. That's why the intro said, imagine if your loved one touched you and you couldn't feel it. Yeah, that would be crazy. So yeah, he and his team actually discovered this ion channel, and they called it piezo after the Greek word for pressure, which is piezo, right? And they discovered two of these receptors, which is piezo 1 and piezo 2. They also carried out an experiment using a mouse model, and what they found out was that they they knocked down piezo 2 from a mouse model, and they found that putting a tape on the back of the wild type, which is the normal mice, and the piezo 2 knockout mouse, they could actually see that the piezo 2 knockout mouse was acting like nothing was wrong. Meanwhile, the wild type mouse actually kept trying to take off the tape at its back. So that's to show you how that the fact that the mice were able to feel, or mice generally are able to feel touch or pressure or whatever, was greatly because of this piezo 2 receptor. And isn't that amazing? Oh, amazing! Isn't that amazing that it's almost impossible to feel, touch, and sense pressure without one receptor? And they also found that this particular receptor is very important for proprioception, which is basically our ability to sense location, movement, action, and stuff like that. So basically, people who have less of this piezo2, they are not able to have coordinated motion. Mice and people, they are not able to walk on a straight line even when their eyes are closed. These are things that we can do normally, but people who have down regulation of piezo2 are not able to do that. And if not for the work of this particular scientist, we would not know what is responsible for that. So I felt like this was just amazing that we are now able to understand why all of these things happen because of these scientists. They also elucidated that this particular ion channel, piezo2, is very important for sensing pain. Now, I'm sure that as the years uncover, we'll learn more about all of these incredible receptors for temperature, for heat, for cold, for pepper, and for mental and pain and touch. We'll learn more about them and see maybe if they can be applied in any way for translational research. But I'm very grateful that the basic research is being uploaded, because it's beautiful to be able to understand why things work the way they work just for the sake of knowing. And yeah, I'm very excited. Again, Nobel Prize season is a very exciting time for me. And yeah, this was me just trying to explain to you guys what some of the science means. I hope that I was able to break it down in a very simple way. If you guys want to learn more about maybe different molecular biology related stuff, put it in the comment section. And also tell me, what do you think about these discoveries? Were you wowed, or is it just what's my business, let's just be living our life? Just let me know how you feel about this, and I will see you guys in my next video. Bye.